Astronomers have just detected evidence of a massive black hole inside the Large Magellanic Cloud, LMC, a dwarf galaxy orbiting the Milky Way, and it's on a long-term collision course with our home galaxy. In this video, we're going to break down the science behind this discovery, explain why it's so important, and explore other famous supermassive black holes that help us understand this one better. Finding a hidden supermassive black hole in a neighboring galaxy isn't easy. Unlike stars, black holes don't emit light. They are quite literally invisible. Scientists detect them by studying their gravitational effects on surrounding objects like stars and gas clouds. In this case, researchers used an ingenious method, tracking hypervelocity stars, which are stars moving at extremely high speeds. Hypervelocity stars are rare and don't just speed through space for no reason. In many cases, these stars have been ejected by an unseen massive object like a black hole through a process known as the Hill's mechanism. When a binary star system, a pair of stars orbiting each other, gets too close to a supermassive black hole, the intense gravity can tear them apart, capturing one star while slingshotting the other out at an incredible speed. Using data from the Gaia Space Telescope, which has been mapping the precise motions of billions of stars, scientists found that 9 hypervelocity stars in the Milky Way originated from the Large Magellanic Cloud. This was a huge clue. These stars shouldn't be moving that fast unless something incredibly massive kicked them out. After careful analysis, astronomers concluded that the culprit must be a supermassive black hole, estimated to be around 600,000 times the mass of our Sun. This discovery is important because it suggests that the LMC has a supermassive black hole at its core, something we weren't sure about before. The existence of this black hole fills an important gap in our understanding of black holes of this size. We know of stellar mass black holes, which form from collapsing stars and usually have masses of a few to tens of times the Sun's mass. We also know about the giant supermassive black holes, millions to billions of times the Sun's mass, like the one in the center of our own Milky Way, Sagittarius A star. But mid-sized black holes like this one in the Large Magellanic Cloud are much rarer and harder to find. If confirmed, this discovery could help scientists better understand how black holes grow. Does a mid-sized black hole like this feed on gas and stars to eventually become even larger? Or does it merge with other black holes in galaxy collisions? These are the kinds of questions that make this discovery so exciting. The Large Magellanic Cloud has been orbiting the Milky Way for billions of years, but it's not just a peaceful satellite. It's actually falling toward us. Astronomers predict that in about 2.4 billion years, the LMC will collide with the Milky Way, causing major changes in our galaxy structure. But what happens when a galaxy with a supermassive black hole crashes into another galaxy that already has one? When the LMC merges with the Milky Way, its black hole won't just disappear. It will start sinking toward the center of our galaxy, pulled by gravity. Over millions of years, it will get closer and closer to Sagittarius A asterisk, the supermassive black hole that already exists at the center of the Milky Way. When two supermassive black holes get close, they begin to orbit each other, forming a binary black hole system. Over time, gravitational waves, ripples in space-time predicted by Einstein, carry away energy, causing the two black holes to spiral closer together until they finally merge in a spectacular explosion of energy. This process has been observed in smaller black hole mergers by gravitational wave observatories like LIGO and Virgo, but seeing it happen with supermassive black holes in our own galaxy would be a once-in-a-lifetime event. Aside from the black hole merger, the collision of the Large Magellanic Cloud with the Milky Way will also shake up our galaxy in other ways. The LMC is bringing stars and gas with it, and when it merges, this could trigger new waves of star formation. In fact, some scientists believe this could even change the structure of the Milky Way, possibly making it more elliptical instead of its current spiral shape. This event is far in the future, but studying it helps us understand how galaxies evolve. Mergers like this are not rare. Many galaxies we see today are the result of past collisions. Our own Milky Way is expected to collide with the even larger Andromeda Galaxy in about 4.5 billion years, so the LMC collision will be a sort of preview of even bigger things to come. To fully understand this newly discovered black hole, it helps to look at other famous supermassive black holes in the universe. These examples give us insights into how black holes form, grow, and affect their galaxies. The most famous black hole is Sagittarius A*, which sits at the heart of our Milky Way. We know it's there because of its gravitational pull on nearby stars, which orbit it at incredible speeds. In 2022, the Event Horizon Telescope captured the first ever image of Sagittarius A*, confirming its existence and providing a new way to study these mysterious objects. Another legendary black hole is M87*, located in the center of the giant elliptical galaxy Messier 87. This black hole is an absolute monster, with a mass of 6.5 billion suns. In 2019, it became the first black hole ever imaged, showing a glowing ring of light surrounding its dark center. Then there's TON 618, one of the largest black holes known, estimated to be over 40 billion solar masses. It's found in a quasar, an extremely bright and active galaxy, where it's constantly feeding on surrounding gas, creating massive jets of energy. What do these black holes teach us? They show that black holes don't stay the same size. They grow over time, either by eating surrounding material or merging with other black holes. If the LMC's black hole merges with Sagittarius A*, it could kickstart its growth, potentially making it as massive as M87* over billions of years. Thank you for watching. If you enjoyed this deep dive into the cosmos, don't forget to like, subscribe, and hit the notification bell for more mind-blowing space discoveries. See you next time.